Hello everyone, I am Professor Caudill. Today we are on 31. So they want us to differentiate this. Okay, so V is sine, cosine, negative sine, T, I, plus cosine T, J, plus K hat. Okay, and then acceleration. That is sine, cosine. Negative sine, negative cosine. Ti plus sine, cosine. Negative sine. Tj. Tj. Okay. So let's see if that's what the book got. 31. Negative sine I cosine t plus k. Negative cosine minus sine t. Okay. Easy, easy. 32. Lockheed Martin F-35. Two lightning. Takes off. Okay. So, I don't know. You could just say, you know, a fighter jet takes off. You don't need to say all that. But anyways. Aircraft carrier. Planes going this way. Okay. We have some water. Let's do some water here. Takes off aircraft runway with a runway length 90 meters. So 90 meters. So we know X naught, we know X, we know V naught. We know gravity. Okay. So I did not know that there's a catapult. There's actually a catapult on the aircraft carrier. It's really interesting. So at the point of leaving the deck. Okay, so say x1. So at x1, so the acceleration, oh, I don't know. I want to say like a of x, but I don't know if that makes sense. Okay. Well, we know they're talking about, let's say this is the tip of the boat. Okay, so it's saying 30 degrees, 5. Okay. Okay, so I'm thinking we solve for the x because you got to think gravity isn't affecting the horizontal acceleration. So I'm thinking they're wanting the horizontal component of acceleration. So if this is A1, okay, so then we write A1 is 5 cosine 30 I, and we don't care about the y. So we'll do 530. So 4.3. Okay, so I'm getting a horizontal component A1x. Okay. So I think we use one of our old equations. Um, not that. Probably one of these, right? One of these equation of motion. So I'm thinking we use one with two accelerations. Um, Maybe it's a situation where they gave us like all this information about when it leaves the carrier. Maybe that's just like unnecessary. You know, sometimes the textbooks will do that. They'll give you some unnecessary information to make you think. I haven't seen the textbook really do that though. So this would be a first. So I'm looking for acceleration. Did this break? 1/2. There should be an A here. Pretty sure this broke. Maybe I need this here. Okay. Okay, there we go. So I'll have to re-upload this to GitHub and fix that. Um, no worries. Still doesn't really help because, I mean, it helps, but man, okay, let's see. So what do we want to know exactly? What is the initial acceleration? We need an equation that has two types of acceleration. Okay, here's total acceleration. It's gotta be this one, right? But isn't that's for centripetal motion, I'm thinking. All right. Time to kind of break out the tough tools. Okay. So constant acceleration of 5 at 30. Maybe we're missing a something. Man, this is taking a minute to load. Okay, so V naught V. Okay. Time after takeoff, 5 seconds. Oh, did it say that? It does later in the problem. Okay. Maybe I should ask it to. Do I ask it to suggest a function? Input. I want you to suggest Not. So the reason I'm doing this is because we already have like calculator made for these. I don't want to become totally dependent on the language model. Um, okay. To solve this, we can use the equation of motion, v squared. Kind of ugly because it's not in LaTeX, and not necessarily convinced either. Looks like they're solving for A naught though. So they're not even using this. Okay, so let's see if that works. V squared, and this is an even problem, so we're not even gonna be able to check our answer. So they're doing equation 5. Okay, so they're doing v squared is 70. A is A. 90, 0, 0. 24. So A not 245, 9. Okay. I'm getting 27.2 meters per second squared. Okay. So that's pretty fast, I guess. Uh, I guess it makes sense. Maybe they gave us this because, you know, there's more to this than just that. So let's see. Write the position and velocity. Write the position and velocity. Position and velocity. Okay. Write the position of velocity. Leave the deck. Does that mean like leave, or like leave here? Like leaving deck or leave here? Probably the edge of the deck, right? So they want the velocity here. Okay, so we know the velocity here is 70, right? So I'm guessing it's 70. T or something like that. I don't really know what they're asking. Well, okay. If we know A of t is 5 meters per second, then V t is 5t, and then RT is 5 halves t squared meters per second plus C2. I think that's fair enough. All right. C, what altitude is the fighter? 5 seconds. Okay, so now we need to know the Y component. So we know so it's 2.5J. So A 1 Y 2.5. Okay. So you want so T 0 final T is 5. So they're looking for displacement in the Y direction. Okay. So I'm thinking equation 4. Equation 4, so we have displacement is what we're solving for, right? Acceleration is 5. Time is 5. Initial velocity 70. Initial position. We say 0. Yeah, we say 0. We're using y's here, so when I type x for displacement, I'm referring to y. So I'm getting 412 meters high after 5 seconds, which it sounds reasonable. What is the velocity and speed at this time? Okay, velocity and speed at this time. Should be 25 meters per second. Then the speed is 25 times 5, 125 over 2 is about 60.5. What is that? Is that meters? I think it's meters. I think it's just meter. I don't really know. No. Oh, they're not asking for position. So I want to say the speed is 25 meters per second, but I know we've gotten that wrong before. They like to do speed as the dot product. So I don't really feel comfortable doing that. Okay, so they want the how far it travels horizontally, so we're gonna do just the horizontal, so that would mean V. Okay. Um, we're gonna use equation 5 again. Okay, equation 5, so we're using 70. Acceleration is 4.3 this time. Displacement is what we're finding. 0 initial velocity. Okay, we need to redo this. Okay. Equation 5. Final velocity is 25. Okay. 25. 4.3. Close enough. X 0. Initial velocity is 70. Oh, is it -5? Okay. Maybe it's negative 4.3. Displacement X, initial position 0, initial velocity. Okay, I'm thinking 497 meters horizontally. All right, that's kind of a tough one, but we can move on. $33. Okay. And this is 200. So we know, it's going to go Y, then Y2 is 0. Gravity. So I'm thinking that these are the knowns. I wonder if the language, I just want to check. I don't think this is necessary, but I just want to check if it would catch gravity. If it will even say gravity. Do not forget to include gravity. Okay. If needed. So yeah, it's work in progress. So what are we trying to find? Trying to find T. Okay, so we know probably this. So is it 0 equals G squared over 2 V naught so T should be two answers, A and B. So we should get like a peak, because this will be like a quadratic, we should get like a peak value and then this value. So we're going to want the bigger T, I think. And we want to choose a positive value as well for the context. So we're going to do equation for 0, negative 9.8, T, 200, 0. Okay, so 40 seconds. Now I want to see. Okay. How far does it travel horizontally? All right. Okay, so this is going to be tough. So horizontally. Maybe it's not too bad. So we're just solving for x now. So we're gonna use equation 4. Okay, so displacement is what we're solving for. Negative 9.8 time 40 seconds. 200, 0, 160. All right, let's check the answer. Let's hope we are right. 33, 55 seconds, and 110. So we're way off here. Way off here. So first, I want to check the units, make sure the units are correct. Okay. Okay. 33. We can recalculate this. What do we use? 4. So displacement is actually 1.5 meters. We started. No, we want 0. Negative 9.8. T 200 1.5. All right. Let's try this. Okay, so they say X. Okay, so it's 9. It's actually 9.8 because we're going down. Okay, so that kind of helps me intuit this a little bit more. So 0. So these are Y's. So I wanted to swap. Swap X. Now it wants negative gravity. This is driving me crazy. Okay, so here they did what I got. Except how did they get? Oh, that got. I see what they did. Also, they just kind of just ignored the negative sign here. So I needed to double check. Double check the needed to check that. Okay, so this gave me 40 seconds. So 40 seconds. I'm thinking like real life. Like fire a bullet. 40 seconds. Like that's super long. That is really a long time. Okay, so maybe Maybe I put it in. Maybe I put it in the calculator wrong. I think I did. Might have swapped these. So we're using equation 5. No. We're using equation 4. So 0, negative 9.8 t. Initial velocity 200. Position 1.5. 40. We're still getting 40. So okay. Let's try this with this. 40 meters per second or 40 seconds doesn't really make sense for me. We're using the same equation. Okay, that's good. Okay. So is there something wrong with our calculator? It's saying Vy is 0, so they're saying this is V not X. So V not Y is 0. V not Y is 0. Okay. That changes everything. So 0, negative 9.8 t. Initial velocity is 0. 0.5 seconds. Okay. Now, how did this not help me? This is wrong. V not. How do I fix this? Ensure the initial speed V naught is framed correctly. V naught X and V naught Y be specified. V naught X, but we want V naught Y. Okay, yes, we want V naught Y. Okay. So here we can make it get the right answer. And they're getting 110. Book got 110, 33, 110. So they did use that. So what is this equation called? X is that. This is T. This is so VT. VT plus something. It's gotta be this one, right? So I know I haven't really used F2 at all. Maybe I shouldn't be using the average velocity. Oh, we missed this one. Okay. So for equation 2, solve for this velocity is 200.550, 110. Okay, TB. X is T. This displacement is TB. Time times velocity. It's kind of ugly now that it's man, that's kind of annoying. 10 minutes. Now T's first. So now I really want to just change it. Um 2x times is 0.55. Okay. All right. I think we can move on. This is a tough one. Um, okay. Cool. Cool. Yeah, so this it's like we're kind of I mean this is if anything's prompt engineering, it's this. There's nothing more prompt engineering than this, I would say. Don't mind me, I'm just marveling at my own code. Want to... I'm gonna repost this to GitHub because I had the symbols in the wrong spot. So I need to fix that for you guys. Okay. 34. Tabletop. Our initial position is 1 meter. Hits the floor at a point. Okay, so it hits the floor 3 meters. Okay, so y naught 0, x naught is 0, x is 3. I think that's what this is saying. Okay, we know gravity. -9.8 here. We can say V naught is 0. V naught in the y direction is 0. I'll say V naught x is about 0. I mean, it's rolling. I don't really know how fast it's rolling, but I'm guessing it's rolling pretty slow. How long is it in the air? Okay, so they want to know. So we're solving 0. So we know the final y is 0. We know we're solving for plus 0 plus 1. So I'm thinking it's that and then t something. I think that's how long it'd be in the air for. Oh, let's try. Equation 4. So 0. Should say final displacement. Okay, -9.8 e 0 1. Okay, so I'm getting 4 5 seconds, half a second, so 1/1000. 1 1 hits the floor. Okay, so makes sense. What's the speed of it as it leaves the table? Speed of the marble as it leaves the table's edge. It's like, are you really asking me to calculate the velocity in the x direction? I just want to say 0. It would make my life easier if it was 0. So I'm gonna unscientifically just say it's 0. What's the speed when it hits the floor? Okay. So we will use equation 5 for that one. Equation when it hits the floor. So we're solving for when it hits the floor. So we're solving for B, -9.8. Displacement is 1. This should be final position is 0. Initial position is 1. Initial velocity 0. So I'm getting 4.2. Final velocity of y direction. Okay. Yeah, with that, I think we can end it. Yeah, I'll upload this. One thing we had to change today is we had to move this up. We had to move this here. So if you had issues with some of it, it should work now. I'll upload this as version 8 because we didn't really change anything major. I guess we did add this. I don't know if that's really that really counts. I don't know. All right, thanks for watching.